Hello everyone, welcome to another episode of the Codersarts. So, today with us we have a special guest, Faizan Koul. So, he is machine learning engineer and also enthusiast. Okay, so today we are going to talk about different aspect of machine learning. Along with that, we will discuss like what is the generative AI, what is the LLM, and what are the other things going in research. So, we will try to get as much information I can ask from the Faizan, and Faizan will try to get the answer based on his understanding and based on the knowledge available. Okay, so let's get started. So hi Faizan, how are you?
Hi Jitendra, I'm good. How are you?
Yeah, I'm also doing great. Okay, so before going to deep dive of these questions, okay, so first brief about how you started your journey in machine learning, and also if you want to discuss a little bit about your how was your college days, what was your stream, and how you get to know machine learning is good for you. And so basically how was your transition is machine learning, like from college to this journey. So brief about that things, okay, and then we'll go to the deeper of the subjective question in depth of the this AIML questions.
Oh,
Okay.
sure. So initially, I've been like I did my studies from my hometown only, Jammu and Kashmir, and then I went to do my bachelor's in engineering from Dehradun,
Mm,
Uttarakhand Technical
mm,
University. Then I went on to study in Greater Noida for my master's
mm,
in the field. So
mm,
originally, I was
mm,
not that much interested in machine learning. You see,
mm,
when we guys were doing our masters or graduation, that's when
mm,
this word machine learning popped up originally.
mm,
So
mm,
originally I was into networking and I had been doing my networking masters in networking originally. So after my BTech, actually in my BTech I did a CCNA course from HCL in Noida only. So after that I was
mm,
studying in networking only originally. So I was thinking of
mm,
doing CCNA, then CCNP, then CCIE, and going in a whole different direction than machine learning.
mm,
But then after I completed my bachelor's in like say
mm.
somewhere in the starting era of my masters when I was doing that. So
And what was your stream in BTech, like computer
it
science
was
or?
computer science, general computer science, and my final project I did like in HCL, and that project only was incorporated as my final project in bachelor's. Okay,
Mhm.
so so
Okay.
that was just general networking stuff. So building,
Mhm,
say for example, LMS, how LMS works. You analyze your
mhm,
data through like
mhm,
Wireshark and stuff like that. I was just not that much into Wireshark as well, but just general LMS stuff. So after that, when I did some other courses in the same field as well, so I have done many
mhm,
courses actually from DoCat and
mhm,
whatever
mhm,
course
mhm,
thing name you will see in the field. I was following everything, so
mhm,
I was doing all these courses, these research symposiums and stuff like that.
mhm,
But when I
mhm,
got to talk to different people, so my
mhm,
somehow I don't know exactly where, but I stumbled onto this term in my master's only,
mhm,
that is machine learning. Then I saw like machines can actually
mhm,
learn. So this was my professor, Dr. Rajiv. So he was the
mhm.
first guy who actually introduced me to, I think, language processing in general. So the main thing
So
he,
you are talking about in master, right? Not in bachelor, right?
not in bachelor's. In bachelor's, I was not connected to machine learning in any way whatsoever,
Good.
and I had no
Mhm,
concept of what AI and all this. In general, maybe, but I had zero concept of all these things. So I've not stumbled onto all
mhm,
these. Just networking and general computer science stuff.
mhm,
But then,
mhm. Okay.
when Mr. Rajiv, I saw his paper. So his first paper I read in machine learning was actually on sentiment analysis. So first research
Mhm,
paper, and it was written by Mr. Rajiv only, since he introduced me to the
mhm,
field in
mhm,
some way. So that
mhm,
was in
mhm,
language processing only. So after that,
mhm,
I got interested in the field and I did research. I read other research papers. Then I got to recommendation system. In my master's only, the first paper I wrote was on sentiment analysis only. So that is natural language
mhm,
processing. So in that, what we generally do is like we have this plethora of statements or textual data. We train a model and extract the
mm,
sentiments. So it is, in
mm,
general, it is totally supervised. Okay. So we have these category: is the sentiment positive, negative, or neutral and stuff
mm.
like that. So
Okay, so
yes,
yeah, yeah, go ahead. Yeah, go ahead.
okay. So I can go on this stuff forever. So if you have any questions, you can just
Mm.
ask me. Okay.
Yes, yes, yes. So yeah, so your first project was sentiment analysis. So basically, your professor assigned to it. So basically, getting familiar with machine learning. So I think this was the very beginner level project. I think sentiment analysis,
Yes,
right?
it was actually, it is not, sentiment analysis is not that, extensive. It is
Mm.
extensive, but it's not that huge of a
Mm.
task, right? But at the time, it was
Okay.
something, right? Because at the time, there were not these
Mm.
transformers and stuff like that, or I had not been
Mm.
exposed to all that stuff.
Mm.
So, given the
Okay. Okay.
environment I was in, it was pretty much, I really
Mm.
thought like a machine could, understand emotions based on text. So it was a thing
Mm.
for me. So I wrote a paper on the
Mm.
same stuff, and then I got into
Mm.
recommendation system. That was another project
Mm.
which I got interested in my masters only, and I think that is where my
Mm.
journey actually started for machine learning. Not journey, I would say my
Mm.
interest. Like this thing really fascinated me. Like
Mm.
how a machine could tell you,
Mm.
first it could tell you your emotions, okay, then it could tell
Mm.
you, like recommend you stuff, and then when I came to know about it, I looked around and I
Mm.
saw like it was incorporated in everything. So I was
Mm.
being, bombarded with these recommendation systems all over the place. So then I started writing
Mm.
a paper on that only. So I published
Mm.
another paper in International Journal of Times. So in
Mm.
that, I was like a general research done, what had been done, a historical survey. There's the general stuff, how you
Mm.
write a research paper,
Mm.
the historical
Mm.
survey, and then you know what was currently going on and what we can do. So in
Mm.
that,
Mm.
I had proposed a system known as collaborative filtering system for recommendation system.
Mm. Mm.
Many of like Facebook, Google, not exactly Google. Yes, even Google for their ad recommendation system. So many of the, even YouTube of these
Mm.
huge giants, tech giants use these
Mm.
techniques. So
Mm.
I was really
Mm.
fascinated about that. So I wrote that paper,
Mm.
and then at the same time, I got this opportunity. So I did this internship.
Mm.
So I did this internship
Mm.
from Noida only with MSF,
Mm.
Million Sparks
Mm.
Foundation. So in that internship,
Mm.
what I wrote, it was, I don't know how would you explain it. It was, I don't know, coincidence, chance. Would you call it? I was researching the
Mm.
same stuff and they needed the same stuff, right? So they needed a sentiment analyzer.
Okay.
And so they have this
Mm.
app, Chocolate, we call it, we used to call it. I don't know, I've
Mm.
not been in touch with them
Mm.
ever since. But still,
Mm.
so Chocolate, it was
Mm.
this app. You can find it on Google Play Store as well. So
Mm.
in this in this app, they used to train their professors, right? So all these professors,
Mm.
government professors and stuff like that. So in general, they
Mm.
had this app in which they needed to recommend posts, different types of posts to their
Mm.
professors, which post would be more relevant to
Mm.
that professor or any of the users
Mm.
of the app. And then there was a
Mm.
sentiment analysis as well. For example, in the comment section, so
Mm.
the sentiment
Mm.
analyzer plays a crucial role, even though it is a small project, right? But its
Mm.
applications are
Mm.
so huge in any social media or any
Mm.
app or for
Mm.
any product-based
Mm.
company who want to know what the
Mm.
you know their consumers are thinking about them or what their
Mm.
emotions are towards their particular
Mm.
product, we
Mm.
may say, right?
Yeah, yeah, yeah. So basically, all about machine learning is mostly about processing the huge data and getting the insight, and based on that data, there is any unlimited use cases possible, right? In the form of application, right? Either it's maybe recommendation system, sentiment analysis, or maybe anything that is could possible. Then their data is needed, right? Because there is, if somewhere data is exists, machine learning exists, right? So either it may be normal application, either you need visualizations, or maybe you need different type for like customer data or any insight, because in businesses data is the most valuable thing, right? Because based on the data, the decisions, future decisions, and what are the new things we are, because all the social media have, mm, I think there is no any measure of the data how much the data is available, right? But somehow the new concept like big data, machine learning, so these are new technologies coming, so process all the data. And the machine learning is, nowadays machine learning is giving more value to those data, right? Because there's different using algorithms, there is methods, there are different type of models, and based on that different evaluation techniques. So there is complete machine learning pipeline, not going to depth, was just a first briefing of the importance of the data. So how do you think? Okay, so if you want to, yeah, if you want to go further into how was your journey, then you can continue, or maybe you can then select me this normal question. So go with your path,
Sure,
then
sure.
we will
I will just
come to this one.
incorporate this thing into my journey
Okay,
only.
okay.
So, my journey is like, for example, these two projects. I would discuss these two
Hmm,
projects, and then, for example, you
hmm,
said about data. So, all this comes into this project only. So now it's not really my journey. So it is this machine
hmm,
learning is into it. So, for example, you said this data is due to the fire they call machine learning,
hmm,
right? So, for
hmm,
example, if
hmm,
we have data about anything, so for example, in these two particular use cases, we had data about sentiments.
hmm,
So, for example, comments of a particular app or a particular
hmm,
product, or data
hmm,
about what a user needed, or the sites a
hmm,
user has visited, or the
hmm,
applications user uses,
hmm,
or
hmm,
any kind of
hmm,
that stuff, any background on you. Say, for example, where you
hmm,
went to eat and stuff like
hmm,
that, where you went to eat, where you
hmm,
did your lunch, when you sleep. So, all this is
hmm,
data. So, once this data is collected using machine learning, it could predict what may be the next best thing for you. So, that is how
hmm,
everyone works these days, right?
hmm,
So, yes,
hmm.
that was it.
Yeah, so basically it's all like, whatever the action you are performing over the internet, all are data, right?
Internet,
It's
even
like
for
that.
example, say in your daily life, what you're doing right now in your
Yeah, yeah.
mobile phone, say for example, you use a particular set of apps, right? So, for example, you
Hmm,
use
hmm,
Facebook, Instagram, right?
hmm,
So, if a
hmm,
company, say for example, I have a store, I have this
hmm,
clothing store, right? So, I know
hmm,
which applications you use. Say, for example, you are too much into Facebook, you're too much into Instagram. Not
hmm,
everyone is, almost everyone, but not everyone is into
hmm,
those particular apps. Say, for example, you're into
hmm,
Pinterest, right? So,
hmm,
if a seller or this company who is selling shirts would like to target you
hmm,
per se, right, as a person who use these
hmm,
particular apps, right? So what they will do is
hmm,
they will specify they will just use these channels to
hmm,
target you, right? They will sell their
hmm,
ads
hmm,
and their shirts and whatever. They will send it to you again and again until you buy it, right? So
hmm, hmm.
this is
Yeah,
how it
yeah.
works. So data is everything. Whatever you do, whatever you read, whatever you consume, we live in
Hmm,
a consumer
hmm.
based society. This is a fact,
Okay.
right? So all
Hmm,
this is
hmm,
data,
hmm,
and it
yeah.
could be used to predict you, what you are and what you are
Hmm,
gonna do next, right?
hmm, hmm.
Yes.
Yeah, yeah, definitely. Like whatever the day-to-day activity you are doing, like it's maybe like what different things you have eaten, what are different. It's like, also data can help you, predict your personalities. How do you plan your future? Not future. Productivity. I'm talking about. You can predict your productivity. Like which day I was very good, which day I was, I have some illness or something. Anything, I was that day I was not good. So basically, data can also capture it's all, I think. I mean, anything, taking the action that has some, responses. If there is input output, we can say. So everything is data, either the personal or the internet. So all these are form of the data. So how you can want to use that data, that depend upon, your use cases. And based on, like, if you want to use your personal productivity or a personal need, or maybe for businesses, or maybe for any recommendation, or maybe what about day-to-day decisions you are taking. So based on the, finally the data is what will you use to data is helping somehow, take your decisions, and maybe helping to take better decisions, right? Or maybe improve your overall, obviously the uh, final result you come talking about environment and decisions, what the final result and all the things are. Okay, so you have done btech, okay, then master you have also done, and also you have many research paper you have already
Hmm.
published, right? So I think yeah, so based on that research paper you have got some projects. I think first internship are talking about, you got the internship in some
Hmm. Yes.
right? So if you want to talk a little bit more about after that or later journey, or
Well, I think you
so
know
can
my
we go to
next
the
point of my journey left me to you only, right? So I did my internship with you as well, and we built many
hmm,
projects together.
hmm,
So it was a
hmm,
very good
hmm,
experience there also. Hmm.
hmm. Yeah, okay. So you want to explain more, or should I go to the that
Sure,
question?
you can ask me any questions for.
Okay, okay, fine. Okay, so just brief, like till now, your journey. Okay, so first brief, what is machine learning? Okay, okay, and not I'm talking about the more academic term. So more as we can say, more as a general persons who everyone can understand. So what is in your term? What is machine learning? And why everyone should know at least about this, like just like you when you are at school, so normal like physics, chemistry, math, or basic mathematics are mandatory for everyone, right? So that was there. So how machine learning that is essential for whatever the person, anybody, as a normal skill. So how these are important. So basically first brief about what is machine learning in your term as a general people, so they can understand, and then based on what are the essential part, and we can say the essence for the anyone, what is their importance.
Sure. So let me start with the term machine learning, right? So machine learning, the
Hmm,
term itself
hmm,
says, so machines are learning. So
hmm,
from my
hmm,
research, this term was first, not exactly the term, the concept as a whole was
hmm,
brought
hmm,
up by Turing, right? Everyone knows Mr.
hmm,
Turing, right? So
hmm,
what he
hmm,
said
hmm,
actually was somewhere in these lines. So he said that machines would actually
hmm,
learn itself, right? So what
hmm.
it that means
Yeah.
in computer sense is like at that time, so for example there was symbolic AI, so this gave rise to a
Hmm,
symbolic AI term, right? So in this
hmm, hmm,
he
hmm,
actually meant was a machine could write its own instructions, right? So you have a set of instruction
hmm,
set
hmm,
given to your hardware from the, right now for example we give our instructions to the hardware.
hmm,
Say for example we write in Python, it goes into C++, then the assembler works and whatever goes. So at the end of the day,
hmm,
uh, the machine has some instructions. So that is given
hmm,
by the human itself, right? So the concept here
hmm,
was
hmm,
the machine would itself alter its own instruction set, right? So this is Turing saying.
hmm, hmm,
So the machine would alter
hmm,
its own instruction set and hence would learn itself
hmm,
and would act on its own self,
hmm,
right? So
hmm.
this is
Yes,
where
yes.
it actually came into existence. So in general, we can speak about machine learning as like
Hmm,
machines imitating what human-like capabilities. For example, I'm looking at you right now.
hmm,
I'm analyzing, like I based on
hmm,
your face, I see like
hmm,
you're into this conversation. You're
hmm,
paying attention, right?
hmm,
So this is a
hmm,
cognitive, like
hmm,
based on cognition, right? So for example, I see you and
hmm,
I based on that some thoughts come into my mind and I analyze that stuff. So this is
hmm,
cognitive learning in such way, right?
hmm,
If we look at it from
hmm.
that
Yes,
perspective.
yes.
So machine learning in
Hmm,
general would be imitating these abilities, right? Seeing and
hmm,
deducing some sort of results from that, hearing and then
hmm,
deducing. Say for example,
hmm,
even here sentiment analysis, although this is small term, but it could be
hmm,
a good thing to understand the essence of machine learning. So for example, based on your sentence, I can when you tell me something. So for example,
hmm,
you tell me something and I know like he's angry, I think, right? Or he's not
hmm,
interested
hmm.
or something like
Yes,
that,
yes.
right? So all these things.
Yes,
So
yes.
this imitation here, in general, our senses, seeing
Hmm,
and giving cognitive
hmm,
responses, hearing and speaking as well,
hmm,
based on
hmm,
something, given some
hmm,
data,
hmm,
speaking and doing all the artistry in
hmm,
there. For example, building paintings,
hmm,
singing, music that
hmm,
requires
hmm,
artistry, right? So all these things,
hmm,
imitation of all these things is what we call today machine learning for a general purpose, right?
hmm,
This definition goes for a general
hmm,
audience as well. So in today's time,
mm,
I don't think it is possible to escape machine learning, right? So, for example, you use your phone, you open,
okay.
even you,
Mm,
if you have taken, say, for example, a group of people went to camping, they took some clicks there, right? In their gallery they will
mm,
see like there is machine learning going on even there as well. Say for example,
mm,
you'll see in journals, say for example in Android or even in iOS, you'll see it will show you these spaces,
mm,
right? It will show you these
mm,
spaces,
mm,
like, is this you, is
mm,
this the person? For example, most photos taken, then it will, you know,
mm,
see which photo is taken by whom, and it will relate those photos, like based on some similarity measure it
mm,
could do that. But it is machine learning in your, you know, devices. So machine learning is everywhere. In
mm. Yes.
teaching, machine learning is helpful in, for example, video analysis. So for example, based on when we take
Mm,
camera photos, like for example I take a picture, or in
mm,
this particular video let's talk about,
mm,
you could see like
mm,
in general, if you
mm,
take the output, like and use a normal camera, you'll see that the
mm,
image is not that good, right? But when you use a certain a
mm,
particular application, right, for example Pixart or this particular
mm, mm,
application, so
mm,
when you use this
mm,
application you'll see like the video is certainly better, and you don't have to manually use any particular thing or any
mm,
particular filter to do that, right?
mm,
I mean, you can choose that,
mm,
but
mm.
in
Yes.
general, now you don't have to. The machine will itself tell you like this filter goes best with this
Mm,
particular thing. So that is where
mm.
machine learning today.
Yes, yes. Hmm. Yeah, yeah. Just I have one question. So basically, yeah, fine. I got the idea. But so suppose, so as a, so suppose who know the machine learning first, as a, like suppose you are computer scientist, not to computer science, sorry. So maybe you are any doing master or bachelor or anything you are doing. So maybe you are a student and then you are learning
Mhm.
as a,
Mhm.
curriculum, right? You are doing. So that is one perspective. So because those person know, how the things are going happening, so where we are using machine learning term, what are the different concepts are utilizing. So but as a normal person, see, I'm non-tech guy, right? I don't know, like, so to whom, to me, what is the importance of machine learning? Because I don't have any educational. I'm not talking about educational. I have understanding of basic education, but I'm not no more depth about machine learning. Because suppose I'm using as a non like normal person who just like, so plus two, or maybe I'm not talking about whoever the person who haven't know anything about machine learning, right? I'm talking in that term, okay? So how this thing going to impact that those persons? So or should that person know, or how they can get to know this idea, like where, or maybe I'm not getting the exact questions about that. So how these things, maybe that a person or that person should know this, like, is that good for know, good to know these things? So for those non-tech guys, not non-tech, non-machine guys, I'm talking about the person who don't know anything about the machine learning. So as general people, to how they will try to understand, and how this thing going to impact those persons, anything? So I
Mm,
hope I
yes,
got my point.
definitely got your point through. So let me just say what I understood. So for example, you are trying to tell me like you are asking about how general audience see machine learning, or do they
Hmm,
need to really understand what machine learning is per se,
hmm,
not for technical
hmm,
person, for a non-technical, or is there, if
hmm,
there is a need to understand machine learning, right?
hmm, hmm. Yes, yes, yes. Should they know or not? Because that is not
Yes,
mandatory
yes.
for everyone,
So
right?
it totally depends on interest. So, for example, in today's era, you cannot skip machine learning. So, but that doesn't mean you to
Hmm,
have to learn machine learning, right? But it is
hmm,
pretty
hmm,
evident that you don't have to,
hmm,
you cannot skip it. You,
hmm.
like I said, in this video we are
Okay.
using machine learning. In our phones we are
Hmm,
using machine learning. In our day-to-day life, for
hmm,
travels and everything, our
hmm,
day-to-day lives, we are using machine learning, leaving the big stuff like chat
hmm,
gpt and stuff like that aside. But we are using machine, but I
hmm,
don't have to know it. Being a consumer, if I'm a consumer, I don't have to know how
hmm,
things work. As long as I get my audience, say for
hmm,
example, as long as my video looks
hmm,
good and I look
hmm,
pretty cool in that video, I don't have to know what are the inner workings of
hmm,
those things,
hmm,
right? But as for
hmm,
what I think, like uh, every person. based on human behavior. Every person will have some sort of curiosity why this is working like this. So for general understanding of machine learning, I think there is need for only one particular algorithm. So with like you don't have to scrutinize that algorithm. You just have to understand, like, look at what that algorithm is. That actually I think everyone should know, look into, technical guy or non-technical guy, a general perspective of neural networks. So neural networks is that particular algorithm which, like, in general imitates your own behavior, like all your neurological behavior. Not exactly, it's just a huge oversimplification of our brain, but still, neural networks, if you just know how neural networks work, you don't have to know how neural networks work, but a general understanding. So that should be enough for those people who find this field fascinating or stuff like that, who want to go into this stuff uh, in general only, not in depth or do that kind of research. But they just need to know one single algorithm, and it will give them a general understanding of the stuff. And otherwise, I don't think it's necessary for people to learn this kind of stuff.
Yeah, yeah. I have in my mind. I have some question, not question. I have some. I want to add on something. So basically, see, before when the mobile was first time came into the picture, or when we are utilizing the machine and first time using internet, like you get to access of the information data. So those days people were not, whoever the company either developing the app, so that time technology was not that mature, and that they have not that level of cognitive thinking till now. What other things are invent of LLMs or these open AI, lots of things are happening. So but nowadays I was thinking, suppose you are a normal person, if you are using mobile, so I'm not mobile, anyhow you're connected with internet, you at least you should be more smarter, not as a like person, like you cannot like as a dull person you cannot just be use your phone, because you don't know whoever the person. Suppose nowadays like audio device, and like synthesis voices, person is talking, you don't know like is this your real voice, or maybe somebody other has modified your voices, whoever talking about, right? Now, what type of these are machine directed, or this is automated, or the real thing. So maybe if we want to be more secure and want to be safer, okay, also these are things are important. So as that perspective, as that things keep in mind, like how much safe you are, how much to access some of the data, and how to you know prevent the risk from all the things. So as a suppose just as a normal talk, these are part of digital literacy, as a person, you were like whoever somebody doing some transactions, so you can share some OTPs from unknown person, right? So that is some basic literacy. But as a part of machine learning, so as like some we are generating the content, right? So nowadays using machine learning techniques, so there is LLM techniques. So but still there is part of authenticity, right? So is this information is correct or not? So I think still these are going to more deeper, because these only because as a normal people, basic information, right? Which color, what are the different color of my shirt you should prefer, what are the different according to my skin, what's different persona, or we can say what different color match to my skin. So as a consumer, this smallest amount of information needed. But as I'm thinking, as a current AI, the speed of AI is innovating or automating the task or do this. So, but I think if you are an internet person, somebody who has coach or expert in those things, and they can at least give you the basic idea. These are the things you can should take care, and then you can prevent lots of being frauded by some card information. Maybe like right now you're saying face detection, right? There's no lots of the face detection they're using. Maybe if you're suppose if you're Aadhaar, so lots of security concern might be somehow you're connected with your phone, or maybe somehow connected with share your data, right? So based on data, they maybe they can unlock your phone because your face is available, so face recognition technique. So I was saying like nowadays people should be more smarter so that they can use the larger perspective of the technology or even the user, because no one going to avoid the use of machine learning. Okay, so maybe every phone, maybe nowadays most of the phone are still some legacy like rule based system, but now after 10 years, so there might be more such app, they will, most of the your do task will do automatically. You just schedule this task, they will do this. I'm just giving a just imagine the imagination, there might be something different. But I was thinking as a person who at least know what are the different things, like suppose recommendation system. So is somebody sitting on the server or setting the which movie you need to know? No, that is not working, but at least you should know. So these are some algorithm they are implemented, so this will work. Suppose somebody, sometime we are talking currently, so maybe somehow is generating this text, like what are the text we are talking, so maybe this text is also generated. So at the person who know, yeah, this is the part of machine learning, because somebody is not writing this text, we are talking, right? So transcripting this part. So this more, I think people should be more smarter and at least knowledge of these things. Like not I'm going to try to implement any algorithms, but at least should like these things are part of machine learning. These are, it's just these are history, these are chemistry, these are math. So these are also should know these are machine learning. I'm talking about that. So as a this perspective, I was thinking nowadays persons should be, or maybe at least the whoever the nowadays now student are learning in their schools, somehow nowadays coding are introduced in 6 classes even. So I think this basic as a foundation part, not as a part of should go with a deeper of the technical term of the machine learning, should be aware, because this should be a normal subject itself. Because AI should be a, it's obviously the root term is AI, then machine learning. Okay, so okay, so just give me a brief idea what is AI, machine learning, how this hierarchy work. Okay, so
Okay, so
just give
machine
me.
learning, AI, and all this hierarchy, how it works. First, I want to like pay some
Diff-
emphasis on the things you said actually. So that is like, uh,
okay,
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 so it would
okay,
be
okay, fine,
like
good.
AI literacy would call how important it is. So I actually find this is pretty interesting thing. So I think we cannot, leave the sight of this particular thing as well. I think AI literacy is something which we
Hmm,
should take
hmm,
seriously because in future everyone is saying like all the big people and all these tech giants, their CEOs and people like that, they are telling like
hmm,
AI is gonna rule the world and we know like this is actually a possible thing. So I think
hmm,
AI literacy is
hmm,
pretty important for every person in school,
hmm,
even in school. I think people should learn about that
hmm,
and at a personal level as well.
hmm,
So when I say
hmm,
personal level, I would say, for example, there was this movie and her is the name of the movie. Maybe you have heard of it. So there is this AI and this person talks to him and he doesn't have a mate, a wife or a girlfriend. So he talks to this
hmm,
AI, but this AI is very intelligent, right? So when he talks to it, he bonds
hmm,
emotionally with this AI, right? So when he bonds with
hmm,
it, he
hmm,
doesn't know that this is an AI program and it's an actual person, right? So at least you should have that much
yes,
understanding that AI is a thing and this is a possibility, right?
yes, yes, yes,
Now coming back
hmm,
from there, there are
hmm,
big things as well, but I think as long as the big giants take care of the security on their AI or the people who manufacture these AIs,
hmm,
as long as they keep a close watch on the security of these particular, you know, robots
hmm,
or whatever programs or whatever intelligent mm, or, applications you would say they build up, as long as they you know
hmm,
keep the security on those things strong, I don't think the common people need to worry about it. But because it will just make their lives
hmm,
easier. But if used as a bad thing, then there is a
hmm,
problem, right? If used for negative. So now coming back to your
hmm,
question. So for AI and machine learning and all the stuff that comes with it, this is actually pretty big stuff. So I think, say for example, AI, to my understanding, different people, uh, define these terms differently. So, from what I understand is, from my understanding, AI is the big canopy. Okay, so this is like the big. umbrella term which we use, and under it is are many things. So machine learning is the computer vision, natural language processing, and all the other stuff that comes it. So, for example, in the beginning, I said AI is imitating. For example, machine learning is imitating this particular, you know, human behavior. So, for example, looking at things and hearing. So, if we want to classify this, as you said, hierarchy, the AI hierarchy would be AI would be on the top, and then there would be computer vision. So, for example, imitating how we look and understand, that would be computer vision. Imitating how we speak, that or understand speech, that would be natural language processing. So, and machine learning again is actually used quite interchangeably with the AI term itself, but not to a certain extent, like only to a certain extent, because artificial intelligence, the word intelligence.
Yeah, I understand. I'm not talking about like depth and disk definition. I'm just talking about how the like which term like AI is the top, right? Then that comes machine learning. Under machine learning comes deep, deep
Okay.
learning, data science, or we can say computer vision, NLP. So just give
Okay.
brief, not detailed definitions. I'm understanding
Would
that
be
you
yes, that
in
would be
depth.
a bit
Okay.
complicated. So just give a general understanding. So
Yeah,
intelligence,
because
artificial intelligence. So intelligence is in general like our intelligence, how we know what is good or how we know what we pursue, how we know, like, for example, improvisation, that is also a kind of intelligence. So that intelligence is a general term, but in that thing are many small terms. Like I said, computer vision, how we see and understand what's going on, how we speak and stuff like that. Deep learning is another part of the same canopy. So that would be, deep learning would be imitation of the brain, how neurons, attack, talk to each other, how we learn. And machine learning is in general. So, for example, we have and deep learning even. So, deep learning is actually a part of machine learning as well. So, machine learning is this huge term, right? Machines learning. It says itself, right? And deep learning is one way how machines learn. For example, in machine learning, we can see there are many algorithms. Say, for example, there are decision forests, there are, and we don't want to go into those technicalities, but to name some algorithms in general, it would be SPMs are there, and there are decision trees, random forests, and isolation forests, and many other algorithms like that. And in deep learning, we focus mainly on this one algorithm, which is neural networks, which in more simpler terms imitates how our brain works, is an oversimplification of our brain, and that's it. We give it data, and it on the basis of that data, it says what next.
Okay, let me simplify this and that you can correct it. Okay, so I'm talking about AI first. So intelligence is top, then under intelligence that is called artificial intelligence that is called machine learning. Under machine learning there is many term, but I'm just giving the most popular one, right? Under the machine learning will be computers visions, okay, NLP or natural language processing, deep learning, or we can deep learning one part is data science is one part. So obviously data science is one uh, part of the machine learning pipeline, because this is not different thing, but obviously there is in machine learning there is a different term, right? Data processing, then model creations or model testing, training, then evaluation. So in that part, pre-processing or maybe EDA part, explanatory data analysis. So most of the EDA part is data science. Data science is not separate, like that is not separate concept, because whole thing about data scientist, understanding the data, obviously many tasks like visualizing the data, getting the insight from the data, loading the data. So these are different things. So as a most of the terms, so but these are different. We can say categorize as a obviously can be as a category, right? Because and different jobs are available. So in machine learning, okay, data science, computer visions, okay, and NLP, deep learning. So inside there are many other concepts, okay. So yeah, so any other term like this popular one, there may be deeper many term, because inside you go deep learning, there may be different algorithm, ANN, CNN, RNN, like this. But not talking about as a no, expert person, as a like as a normal idea. So is
Yeah,
any
so
more category like that?
yes,
And
so
nowadays LLM
LLM,
is coming,
large
generative AI is
language
coming.
model, so those things actually come in natural language processing as well, and natural language understanding, NLU and NLP. So these two terms are used together. So these big models, they
mm,
take everything. So, for example, they take concepts from data science as well. So, what data science is in general, we could say we
mm,
have this huge data and we extract insights from it, understand it better. So, that is data science in general. So,
mm,
there are many things we could go on if we
mm,
go on to scrutinize the term, but in general, that is what data science is, the science of how data exists and how it works. So, yes, that is
mm,
mostly it
mm,
in data
mm,
science.
mm. Okay, okay. How they can should start, and what are the different things they should first learn? First, like first go with general machine learning, then deep specialize in any of these things, or just how somebody should
Okay, yes.
build career
So
in this
machine
one.
learning is quite different from all other streams in computer science. So some would argue that it is a
Mm.
totally different stream, right, from computer science. But I can still consider it same as like in computer science. But for machine learning per se, say for example, if any person wants to be an engineer or anything, everyone would recommend them to learn a language and then go from there and keep trying and practicing and stuff like that. But
Mm,
in machine learning,
mm,
I think the concepts are pretty different.
mm,
So for example, if you want to go into machine learning, you don't have to
mm,
directly go there and start a language like for example Python and all that stuff. I think first you should
mm,
clear your concepts well.
mm,
Say for example mathematical concepts, even physics and
mm,
stuff like that. All the general concepts which you are going to
mm,
use in mathematics. Say for example, you should know
mm,
differentiation, concepts of differentiation, and then the most
mm,
important, you should know arithmetics, not just arithmetics. What you call?
mm.
I just forgot the term. Yes, statistics is there, probability is
Statistics.
there, and all other stuff is
Mm,
also there. So you should know all this stuff, and
mm,
then you should dive into the
mm,
languages. So, for example, go and just learn a language. R Studio, you can learn R Studio, you can learn Python.
mm,
If you're not that good with
mm,
languages or you don't find them interested, go learn Tabulo. Your language are not, everything. So you can. There are many frameworks. For example, this
mm,
BI, Power BI, they say is very good. So you don't have to learn a particular language. You can just
mm,
extract insights from these, you know,
mm,
big tools. So just
mm,
pick a tool,
mm,
get your basic knowledge of or understanding
mm,
of the general concepts of mathematics and stuff like that, and just pick up a tool and play with it. That's your way, and then everything will come to you most
mm,
probably. Yes.
mm. Yeah, but I think if a person is, it's like more like we are going to use mathematics or statistics in more details. But nowadays there is many other things, as a job perspective. There's many things available. There's lots of tools. So obviously, if you just know, what is supervised, what is unsupervised learning, and what are the basic understanding, after then also based on basic understanding, if you don't know a statistic, right, but at least four or five concepts that are, normally commonly used, so that would, but still there is chance, like, there is number of tools. You are talking about Tableau, so there is one particular task Tableau for, visualizations, power based visualization, these are things. Or sometimes nowadays there's lots of framework are available. So if you are not don't want to go as a, level of implementing algorithm from a scratch, because these are different level of, machine learning engineers. What are the expertise, like you want to go as a deeper level, like you want to construct some algorithms, right, or you want to build some model, or you're doing fine tune. So that is one dependent. But as a normal, as a also you have chance, like the person who already created something, right, so you are just using those tools like auto ml. Nowadays there is lots of TensorFlow. So these are things you just know. These are different concept, like how this load data, just put this input or this parameter, this this framework will do everything, like TensorFlow, Keras. There's lots of things are coming. So obviously there is different chance, there is different opportunity. Okay, so how much depth you want to go, right? As if you want to, as a surface level, just how to use those tools, but still they are using machine learning background. Or actually you want to, just like in website development, right, you want to front end, somebody want to back end, somebody want to just, already has given somebody designing the product, somebody UI UX. So in machine learning also there is a different thing, you just want to use those tools and just mimic all these things how the task can perform, and maybe other person in deeper, you can say as a machine learning scientist, not the term machine learning scientist, but I'm talking about as a term of algorithm, like whoever actually writing the code from scratch and who offering you these different what we can say these frameworks. So these are deeper level. So there I think statistic differentiations or other mathematical concept are, or a statistic in details, what are the different hypotheses, what are the different sampling the things work, how the distribution is this. So I think that level of things, these are more important, right? We want to go deeper, but I think as a normal thing you just want to test the water, right? So obviously, or not the test water, as some extent you get the good chance or good opportunity in
Yes,
AI ML,
absolutely.
right?
So
So
it
I'm
is
correct.
totally, like you said, it's totally based on the profile which you are choosing. So, for example, from the perspective of if you want
Mm,
to,
mm,
reach out for a job per se, since that is your end goal and you don't want anything
mm,
else to do, then you don't need to
mm,
go like into
mm,
everything and you do this large assiduous study of everything. You just need to learn a tool and be a master at that tool, and you will
mm,
get a job, right? So, for example, like you said, Tabulo itself, you can just learn Tabulo and that's it. Or you can just learn a Python, a language which is very user friendly. You can learn Python and get a job in that. Learn R programming, but you have to know which tools are are needed in the market itself. But then if you want to go further, you want to do research and you want to actually create stuff. So for example, you want to create a model and you want to go the deepest you can do in machine learning or AI, then you need to, these things won't work. You need to have a deep understanding of all these algorithms, and you need to, have some language, even know probability theory and statistics and all the stuff, all the data science stuff which comes with it, and then you can go deeper into all that stuff. But otherwise, if your aim is to go for a job, you need a tool and you need to learn it and you need to master it. That's it. If you just want a job and that's it.
mm. So we talk about general idea about machine learning. How was your journey? Okay, and then uh, where should we go? So we go with a generative AI. Okay, so go with generative AI. Okay, so how the term generative AI comes in picture, and nowadays there are different, not different. So there is too much hype for this one. Okay, so just brief, like before generative AI, what are the different things people are working, and how suddenly generative AI comes, and now people are everybody creating the chaos, or think about technology going to change. There are lots of app is going to change. Okay, so just talk about, yeah, obviously in background there is transformer, and before transformer there is how the neural networks work. Okay, so this was the thing. So talk about little about the history. Okay, how the things were come into the picture, how the previous development, this was research was going on, and suddenly the generative AI come. Then we'll go with what are the LLM, what are the different things we could build on that LLM part. Okay,
Cool.
yeah, so
So,
go with generative AI.
starting like for example, how machine learning, what was going on in the market. So it was general terms. So, for example, in machine learning was almost everyone was using these two, supervised learning and unsupervised learning. Everyone, and there is
Hmm,
the semi-supervised learning or reinforcement learning, but
hmm,
not many people in consumer-based or product-based environment were using all this stuff. But or actually in academics itself, not exactly in
hmm,
consumer-based system, but then everyone was just using supervised learning. That is, you have a certain target. So, for example, like we talked about sentiment analysis, you have these certain targets, one, two, three, or happy, sad, or angry, or whatever, and you have a certain input, and the classifier
hmm,
will classify based on these targets, right? So this was general stuff. This was going on. But
hmm,
and then there was unsupervised
hmm,
learning in which we didn't have the targets. We just had the training data, and we don't know how to classify or in which particular category those
hmm,
data go in. So there was unsupervised, and then there was semi-supervised. We knew some of the categories, and we didn't know other categories, and that was the general thing. So all this was mostly used in data science, right? So, for example, classifying data into different categories, and making sense of data. So for example, there's a plethora of emails, and you just want to know whether the sentiment is positive from these people or not. But then there came generative AI. So generative AI in general is like we generate stuff. So for example, anything we want to generate. So for example, let's come back to our basic definition of machine learning. So machine learning is like imitation of human behavior or human, capabilities. Yeah, cognitive thinking even. So for cognitive
Cognitive
thinking,
thinking,
there
yeah.
is a total different methodology even. So cognitive thinking is so that is cognitive
Okay,
simulations
okay.
are built. Right? So that is also that can also come into yes that can
Okay,
also
okay.
come into generative AI, but those are the techniques, cognitive simulation and stuff like that. We go into that, but that is not what I was actually talking about. So in generative AI is like we generate speech. Now, in the beginning, what we were trying to do, we just wanted to know is the person angry or not, or stuff like that. Now we want to make a speech which imitates angry behavior. Now we want to imitate a speech which, makes a sweet behavior, or we want to generate music even, images. So, for example, maybe you have heard about this huge model, which is no less than or powerful than Chat GPT itself. So, for example, there is this DALI. It came some time ago. So you give it some text and it will generate an image for that. So that is generative AI. You generate stuff. You make artistic stuff, right? You make any imitation of humans, and you even surpass them in that imitation, so the speech will be better than the speech which you are making, right? So for example, I speak, for example, you ask me a question right now, and I'll give you a definition. You ask the same question to Chat GPT, right? It will give you a huge, detailed description of the same thing, right? So that is how, different things are. That is in general what generative AI is. Do you want me to go into more details or inner buildings or not?
Okay, okay, yeah. Okay. Okay, so what I had understood till now, like so, generative AI basically is generating different things. So, but as a part of the data, so maybe data may be in different format, right? Like textual format, images format, video format, audio format. So these are different form of data, right? So with the just like as a humans, right? So before there was no computer, so we were using this. If we want to writing some letter somebody, or maybe you are creating a assignment, or maybe reading those books, maybe there was some textual data, some visual data, right? And there was some video data, there was some animations, just like we are doing some movies, drama. So that was those things like moving pictures, so as you call videos. There was audio. So these were what are the different format are available. So that time humans are generating. So nowadays as a machine can also generate the information, right? Because there was somehow we program something, and then this will generate these things. So basically what are the different data inputs should be there, based on that computer will generate different type of data, right? But the actual thing is uh, those data will helpful for the humans, right? Because there is no use of the machines, because they are just generating those images. But how we are going to those images, because somehow if you are asking ChatGPT just create just any LLM, like you're saying, just create one plan for recipes, but actually they are giving only giving information, but actually themselves that model is not going to create uh, use those recipe and offering you food, that is that part, that is your part, because they are giving the information. Sometimes later it might be happen, like today we are thinking, okay, I don't, I have mind to want some different food, but as a later AI can also generate, I think, I'm not like later we're thinking like auto thinking robot. I don't know what is the term I'm saying. I was watching one video, so they are robot was just like thinking as humans, sitting like humans, or like just like there is wishes in our mind, so there may be AI has some wishes or think they can uh, you know I'm talking about the more advanced, but just a is a hypothetical situation. I'm not going to it, but as a uh, simpleton, we can say these are different data formats. So in these different data formats, instead of humans, these machines can generate. So that category is called generative AI, right? So in simple, right? Okay. So what is the behind this, or how this technology works? So is there was suddenly the new things term comes, or maybe there was research going on, since some decades, and suddenly we are not aware, and some of the people use those term and came
Okay,
with
so
how the behind the
so
technology
first,
this.
let me tell you like how this thing works in actual. Okay, so how this generative AI stuff
Okay, okay,
works. So
yeah.
this is like so much,
Hmm,
if we see different BBC and channels like that, they're talking about there is gonna be is our
hmm,
future is our future gonna be
hmm,
disrupted because ChatGPT came into play and stuff like
hmm,
that. But I would
hmm,
say like
hmm,
it is not that huge. Like I want to rephrase it. It is huge, but it's not that comical or not exactly comical. That controversial, some people might say.
hmm,
So, say for example, how this thing generally works is
hmm,
so. For example, we have this data. So, in general, how machine learning works is we have this data set, right? So we have this algorithm. We give input to our algorithm and it gives a certain output, right? So this is the general concept of any, say for any algorithm, any machine learning algorithm. Now let's just talk about a neural network. Okay, so in neural networks there is this particular input data set,
hmm,
and
hmm,
we there is this particular output, and in between, let's say it's a total black box. Okay, so now we decide we all we need to imitate anything is to see what is the input data and what we want as an output. Okay, that's all we need, and in between is our different architectures. We call in general we can call it neural networks, right? In between is this neural network, and whatever input we give it and whatever output we it generates at the time of inference, it will imitate that. That's it. That is the big science about it. Okay. Now, if we want to break that down, what it does is these algorithms. We, for example, we give a text, right? I am a boy, or whatever we can say. So, for example, in ChatGPT, we ask him, so what do you mean by data science, for example, right? So, what happens is the ChatGPT, while training, it would have a similar input, okay, and then that input will go in, and what the architecture of this neural model would do is it would disperse all of a sudden. It would disperse this not just tokens. So it will
in form of
take
the
this
token,
from
right?
a natural space, right? This textual data from a natural space, and it will disperse it into huge vector spaces, okay, multi-dimensional vector spaces, and then it will try to make sense of those vector spaces, those representations in vector spaces, and then it will generate an output or match in so for example, if we have multi, and then it will actually match those huge vector spaces with the output which we want, right? So that is how these models work. So in the case of generative stuff, we have multimodal stuff. So, for example, there are multiple output heads in the same neural network, and there are multiple input heads in the same neural network. So, for example, the input would be "I am a boy," and the output would be "He said I am a boy" or "He is a boy," right? So we just match those things, right? We train a model, we give it a thousand or not just thousand, millions of examples like that, and it will learn eventually that if this kind of input comes and this kind of output should be there. It knows that this kind of output should be there based on different mathematical stuff in between, right? That would be checking out the similarity between inputs and outputs in these huge vector spaces and making sense of those things based on all those complex transformations. So, for example, there are many linear, non-linear transformations that the data will go through in different vector spaces. So, for example, first it will do the same thing into a thousand dimensional vector space. Then some kind of transformation will take place on it,
mm,
and then it will do another computation on a 100-dimensional
mm,
space, right? So our cognition is not capable of even going above
mm, mm,
third dimension, right? Our cognition is not that capable, but when we see these models, it uh, it does those computations like I'm not saying like we are not capable of that, we are, but we cannot visualize that. For example, how would you visualize a five-dimensional thing, right? So for example, we say this is one dimension and these are two dimensions. Now this would be three-dimensional space. Then for example, now we have a cube. Now in four dimensions we say we have a tesseract, right? Now with that you cannot visualize that. Maybe you can mathematically, not maybe, we can mathematically compute the stuff after those dimensions, but in general, what is that? So what this machine learning, these algorithms do in general is they make different computations and different transformations in different dimensional spaces in huge, highly dimension. That's why we don't normally do the stuff on CPUs. We have to go to GPUs and stuff like that. So those are different stuff. So that is in general what it does, right?
yeah. So so basically all the processing part, vector spaces, calculations part. So as a common term, so this is part
Yes,
of neural
this is
network. So
what
this
neural networks
algorithm
in
does all the
general do.
things,
Then we
right?
have, say, for example, now you want to pay, say, for
Mm,
example, you have this image, right? You can see my face. Now you want this neural network to just look at my nose,
mm,
or
mm,
you want it to ignore rest of my face. So, for
mm,
example, now there is this another architecture. Okay,
mm,
it is neural network itself. Just it is a different architecture, different
mm,
set of layers. It's called, say, for example,
mm,
attention mechanism. We call it in general term. So
mm. So what is
neural
neural
network
network
is
is
the general
architecture, is
algorithm.
algorithms. It
So
is an
it has,
algorithm,
for
right?
example, RNNs in it and different. Now, how you place
Okay.
those networks and those layers on top of one another, how what computations you do in each layer, that is what the whole
Mm,
difference is. Otherwise, everything is just a neural network at the end of the day.
okay. Okay, so and where the come transformer? So like neural network is algorithm. So where the
No,
transformer
it
comes? The
is the
transformer is architecture.
yes,
So before
it is
algorithm or
both are
after
connected. So,
algorithm?
for example, in
How both are
general
connected?
terms, you could say that we mold this neural network. Now we have this neural network, we have this set of layers. Neural network could be just one layer, one input layer, one middle layer, and one output layer. And neural network at the same time could
Mm,
be 1,000 layers, right, on top of each
mm,
other. Now, how we which layer which keep first,
mm,
what residuals we use, what mechanisms, so for example, what attention mechanisms we use.
mm,
That is how we build a transformer. Okay, so for example, a
mm,
transformer would be, in general terms, we would have to see at its image and at its particular architecture to know what exact layers of neural network itself, nothing else, just neural network. What layers of neural network does it use, and how are those layers
mm,
sandwiched over each other? That
mm,
is how we build uh, a transformer. It is like, you can think of it in simple terms. You can think of it, say for example, we used to play with those Lego bricks, right? So the way the same Lego brick could build you a
mm,
entire building, right? Or the same thing could build you a gun, right? Or the same thing could build you
mm,
some other toy, right? So Legos would
mm,
be this neural networks. How you put these Legos on each other would be how we build these different architectures like transformer mechanism. And there are, how do you cache these, like how, not exactly cache, how you take residuals, and for example how you build these attention mechanisms. And there are some other computations as well. For example, it is at the core all mathematics, right? Sometimes what we do is, so for example, there is RNNs. Okay, so we had, so for example, why would we use RNNs,
mm,
right? We had this dense layers, then on top of that dense layers we attached some sort of recursive behavior. It revolves, whatever goes in
mm,
comes back, right?
mm,
Then LSTMs, why would we use
mm,
LSTMs? We had RNNs, we
mm,
give some memory to it, right? And this mechanism follows. Similarly, we make different tubes to
mm,
the same thing and it
mm.
repeats
Oh,
itself.
okay, okay. Okay, okay. So I have some doubts. So yeah, fine. So neural network is one concept we can say. So the neural network basically how is so how the different networks or maybe neurons are connected, right? So neurons basically neural networks are basically thousands of or any number of layers, different layers. So maybe first layer input, and like first layer in output, next layer input might be happen. So these fashion the nodes are connected or passing the data. So these are common term of neural network, right? But how accurately the your data should be, what are the data you want to achieve, right? So that are the different mechanism you're talking about, attentions, or what are the different recursive the things are using. So maybe so after those different things we are utilizing, so attention, so that are the comes of the part of architecture, right? So those architecture, if some different type of these things are following, so this architecture is called transformer, right? So maybe any those architecture may be any different name, right? Maybe transformer or anything, but currently as a we say as a transform is a type of architectures.
Yes,
Those architecture are mold over
yes,
these neural
exactly.
networks, right? So over the thousands of data. Am I correct? So okay, 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 fine. So now so just define this term. So architecture, so and transformer. So basically, uh,
Okay,
transformer. How
let me
this
just give you a
is
general understanding of
transformer
the
or
whole
this?
stuff. Okay, so first of all, let's take this neural networks itself. Okay, so what is a neural network? It will say, for example, we know how our brain works, right? Not everyone knows, and we don't need, like we say, this is neural networks are over and over 10 times over simplification of our brain only. How neurons in our brain work, that is how neural networks are built. A super duper oversimplification. Okay. So in general, we will say for example, we keep certain neurons at the start, so at input, that we call that input layer. Okay. So at minimum, there should be an input layer, right? And there should be an output layer, right? Or the same neuron could be input or output as well. But in general, like let's just go back. So there was this, say for example, there is this term called perceptron. Okay, so there is this feed forward network and there is this map propagation system. So this stuff is pretty deep. It's like we cannot direct climb into the
So and what are these terms?
this
So
is
what is this
yes,
term
that's what I'm
called as?
saying.
So
So for
where
example,
we use this
like
term?
I'm
So
saying,
what is
there is
this?
a particular chronology we need to follow to go to transformers, where transformers is actually the pinnacle, we would say, at the time, right? And in the beginning there were different stuff, right? So for example, in the beginning there were connectionist networks, right? The same neural networks named differently. In the beginning, before that there were, say, rule based systems and all that stuff. And then there came this term known as perceptron. So neuron and perceptron. So perceptron would be a simple feed forward network, right? We would call it feed forward. So what it does is we input the data and it does a particular computations on that data and then it forwards it. Okay. So that is how our neuron works. If we look at our neurons in the most simple and basic terms, it takes some input, it does some calculations on it, and it gives an output. Okay, so that would be one single neuron. Okay, now we take 10 neurons. Okay, take 10 neurons. So for example, this is 10 neurons. Okay, now we take 10 more neurons. Okay, now we connect those two, and then we can take as many as neurons as we want in different layers. So this is 10 neurons in one layer. So for example, we give it some input. If we give it some input, that would be the input layer. This would neuron set of neurons would be the input layer. If we attach the output of this neuron, we give input to another similar, similar, that would be the middle layer, and then we give output to another layer and output to another layer. So this is your general feed forward network. Okay, this is neural network with feed forward. So we give an input, it does some processes, and not exactly process computations. We give it an input, it does some computations, and it forwards it to another layer. It does some computations. Now it's a process. How many layers or how many computations do we want? One, two, three, four, a thousand, a million, a billion. Okay, so this is the feed forward network. Now how would it learn? It's not learning anything. It's just a set of computations. Now, learning comes when back propagation comes in. So back propagation is uh, this another algorithm which we use on top of this thing. Okay, this neural network. So now, when once we have this output, now say for example in our brain we have. Let me just take things. Maybe it will make it easy. Okay. So say for example, okay. So this is one layer of neurons.
Perfect, perfect.
We give it input, it gives output, input, output, right?
Mm,
So this is just one neural net. Now, how will it learn? So learning comes with back
mm,
propagation. That would be the
mm,
output of these two layers
mm,
would be taken down. Okay. Now we have these layers. Now we have a certain output,
mm,
right? The output is not correct. It is just a computation, and there has been learning.
mm, mm,
We take that output. We see
mm,
what was the desired
mm,
output on that. Okay. Understand how much different is that particular output from what we
mm, mm,
expected. Okay, so now there would be some loss, right? There would be some error rate.
mm,
Then we use this back propagation. We give it back.
mm,
We
mm,
use an optimizer.
mm,
We use an optimizer to reduce that loss. So it goes on like this. So there are different gauges and
mm,
stars, screws.
mm,
First we have this neural network. It does some computation. We attach back propagation. We attach a loss function. We attach an optimizer to it. Now it starts learning, right? Now it can learn. So the first prediction would be less, good.
mm,
Each new prediction will be better than the previous prediction. So, for
mm,
example, if we run it for 10 times or 10 epochs, the 10th time will be better than first. Okay, so this is the general concept of how neurons learn. So, now that we have this learning neural network, what computations we do at each layer, okay, and how do
mm,
we, put those layers on top of each other is how we build a transformer. So, I don't have like
mm, mm,
the image of the architecture of transformer in front of me. Otherwise, I would really go into that as well. But the general concept would be same. This transformer would have certain layers, similar kind of layers. So, for example, this first layer, now instead of just layer of dense layers, there now. So, for example, there are types of these layers, right? So there would be dense layers, there would be RNNs, like I said, LSTMs and CNNs and whatever, right? There would be different types. All these layers would do different types of computations. Okay, not all of them do the same computations. And how we sandwich
mm,
them
mm,
is the architecture. That was your question, right? The architecture and the neural network. So this whole thing is the neural network, right? So for
mm,
example, this whole thing is the neural network.
mm,
How we attach these neural networks or these layers on top of each other, and how do we, how big we make them, and or how small we make them based on and what data we train them on. That is the architect, not the what data we train them on, just how we place these layers on top of each other, how many neurons we use. Those are actually parameters and hyperparameters. Say, for example, what activity functions we use, what optimizer we use, what loss functions we use. So there are different things like that, and what layers we use in particular, and how we join them together would be the architecture. And transformer, to my understanding, is nothing more than an architecture. Okay, but with different computations. Now, when we say nothing more than this term, it seems like it is something small, but it takes years. It would have taken, I don't know how much time for them to do those things, right? So it's just, some mathematical layers sandwich put on top of each other in a particular sequence, doing some particular computations and following some particular, activations, and giving some particular results and doing some particular learning at the same time, using some optimizers and correcting some particular error rates. Okay, and that is at the end of the day what all these things are. Now, what this is, say for example, transformer, that is the same thing. So for example, if we want to build a attention mechanism, we would do the same thing, just not exact. We have to build a different architecture of the same Lego bricks, right? Coming back to my example of Legos, using the same Lego bricks, we have to, put it differently. like I said in the beginning, we can make a huge building, Empire State of building, in using these Legos, and we can build a toy or a computer or anything using these
Hmm.
Legos. It's just how we put them on top of each other.
Hmm. Okay, so I was talking about like yeah, the behind the scene how the generative AI work is a transformer, right? So how this is connected with LLM. So how these are LLM? So just define this term. So what is
So,
LLM are connected with all these scene?
so LLM, large language models, right? So
Hmm.
it is just the things which I just explained. It is the same goes for LLMs as well.
Hmm.
Okay, but there is a difference. So, for example, how we model a language,
Hmm.
a language, a human language, or any other language. Say, for
Hmm.
example, uh, like not exactly even any other language. Say, for example, roars of lions or
Hmm. Hmm.
barks of dogs. We can model those things as well.
Hmm.
So it is just how we model these languages
Hmm.
is what LLMs is in general. So
Hmm.
what it would do, say for example, what is a language model? A language model would be something that would understand human language and and give a proper response. And there should be, so for example, if it's gonna be at the pinnacle of these things, it should have a particular understanding as well. So it shouldn't be just a natural language processing. There should be understanding as well. So the model should take in something, a language, a sentence, or something like this. Say, for example, let's take example of Chat GPT itself. We
Hmm.
take an input, it
Hmm.
does something, right? It's magic. Is this whole transformer thing we call it?
Hmm.
So it does its magic and it gives a response. At the end of the day, it's a chatbot, right? A
Hmm.
chatbot would be a language model. Now, like I said, we have this architecture built on top of neural networks and stuff like that, large if we build it to a very huge extent, right? So, for example, this is one layer and this is one layer. So, for example, there are a million neurons here, a million neurons here. How many connections, if we connect this each neuron to each other neuron in the second layer, how many connections would that be? That would be a billion connections, right?
Hmm. Hmm.
More than like billions of connections, right? So that
Hmm.
is how what these language models is. This is just we take a huge number of these neurons, these layers of neural networks. We take a huge number, we make infinite many, not infinite exactly, a huge number of connections. We train it over a huge amount of data, right?
Hmm.
Data would be a very huge data. Say, for example, millions of records of data. Then we train, like we do this back propagation, which we just discussed, and we do all the same stuff which we just discussed. Only the input would be, in this case, for example, the input would be input, in middle would be this transformer architecture. The output would be output. So, for example, the output should have as many neurons to output the language itself, the sentence itself. The input should have as many, neurons to have the capability to take
Hmm.
input
Hmm.
uh, uh, as this text or whatever natural language itself, right? So
Hmm.
this is what large language models are. This is just uh,
So
we have these huge architectures trained on huge data, making huge connections between them, and thus building a large number of parameters. And we train them on a very strong architectures, thousands of GPUs and stuff like that. And the
hmm.
final product would be a language model, large language model. It's just
Hmm.
like the word said,
Hmm.
large in everything. Large network, large architecture, large
Hmm.
data, and large number of parameters and stuff like that.
Hmm. Okay, okay. So I'm just summarize these things how I understood the LLM. So basically, uh, we language model, right? So before how the whole the transformer part working the same, right? They are also processing the it's a type of helping the large language model to process data, right? But now we are adding number of if you are increasing the number of neurons means number of parameter you're increasing. So large language is only this concept are increasing the number of neurons, and that is called like what are the different company giving their own large language model name, right?
Yes,
So
it
OpenAI
is.
giving OpenAI
Yeah,
giving some other name, Meta giving their Google giving. So is this same Or
Almost. So the thing is the mean. Say for example, how huge we make our network. So that would
mm,
it would be a
okay.
parameter, right? A hyper
Mm,
parameter. How long the network was, what architecture we use. But the main, most important two things are there. Okay. So one is data, the amount
mm,
of data you train these things on.
mm,
Okay. Now you have this huge beast, right? This
mm,
huge architecture, right?
mm,
To
mm,
get the maximum output or to get the maximum stuff out
mm,
of it, whatever we got, the maximum efficiency out of it, we need to train this on huge data sets itself. Otherwise, what's the point of making a huge network, right?
mm,
And then to do that, we need huge infrastructures as well.
mm,
We
mm,
train huge amount of data on huge big architectures most efficient. It's not just the size of architecture itself, it is the efficiency, the particular mathematical functions which those each layers do as well. And then on top of that, you need the right infrastructure to
mm,
train it. That's it.
mm,
That's what large models are. And language models, if you train the same sort of model on language data, it would be large language model. You use a different, slightly different architecture for computer vision tasks. That
mm,
would be a large computer vision model, right? So
mm,
this is just LLMs. I think it
mm,
just caught a lot of
mm,
hype
mm.
and stuff like that.
Yeah, so little bit more about language model. So, what is basically language model? Like processing the humans data, or it's called like a language model. So, before, so how these were working? So, how so before we are not using before large there was no term large. So, how we are using this large, not large language model? How we are processing before?
Good. So in the beginning, like we said, say
Mm,
there was these neural networks or all this stuff is not new. Okay, this is pretty
mm,
old.
mm,
I would say it is from
mm,
1950s. Okay,
mm,
1950s it
mm,
originated.
mm,
These things, say for example, tuning. When was he alive? Like it was 1940s and 50s, right? 19, say for example, to be exact,
mm,
1952 to like in 1950s, we would say they
mm,
used these networks, and say for example, they had to use a separate machine. Now this is fascinating. Now
mm,
in these language models, we use billions of or millions of neurons, right?
mm, mm,
And we train it on a set of GPUs. At that time, they used one machine for one single neuron. Now,
mm,
how crazy is that? They use
mm,
one neuron,
mm,
one machine to train one
mm,
single neuron. So now, if they wanted to use 10 neurons, they would have to use 10 computers, 10 separate
mm,
machines
mm,
to train that model, right? So,
mm,
from that, now what stopped? Why were there like how it grew from that? Now, this is like
mm,
a huge time, right? Almost a
mm,
century. Not exactly a century, but almost a
mm,
century, right? Now,
mm,
what changed? The infrastructure changed, right? So,
mm,
at that time, they used one neuron on one machine. Now,
mm,
on one machine, we use million neurons, right? You see
mm,
how
mm,
Moore's
mm,
law works there, right? The
mm,
infrastructure is contracting itself. So, that is
mm,
why we came up to this point. Otherwise, these language models, what they were simply small models, or
mm,
based, not exactly small models, we will say, based on the infrastructure we had at the time. So for example,
mm,
before 1980s, or
mm,
1990s, even before 1980s, I would say, or 90s,
mm,
there came this huge AI winter, we call it.
mm,
Why did it come? They didn't have the infrastructure at the time,
mm,
but now we
mm,
have the infrastructure, right? Now we
mm,
have huge infrastructure, huge GPUs and TPUs. So that is
mm,
how the language models became large, uh,
mm,
just in proportion, like the
mm,
infrastructure became small, language models became large. That's how it happened. Okay.
mm, mm. Okay. Yeah.
Otherwise,
So
it was,
basically,
yes,
hmm, hmm, hmm. Before also before there was no term large. So before there was still we are processing
exactly.
language model still was there, but there was just small. There is
It's
because
small model.
all. So all the things like obviously language model is basically the language for whom language is basically before was for humans language, but now this term used in term of machine that is called machine model. But as a what are the different languages we are using English, Hindi. So as a human term we can say as a languages, but in term of machine we can say language model, right?
Yes,
Is correct.
exactly. Now in future, say for example, Google, say for example, it has certain translation models. So translation models are also language models, right? It translates
Mm-hmm.
a language from
Mm-hmm.
one, it translates from one language to second language, right? So we have these translation models. Now it will increase the number of language we translate. It will increase. Now it would be able to translate thousands of new language,
Hmm.
because we have the infrastructure now. So it is just
Yes.
based on infrastructure. We didn't have the infrastructure at the time. Now we have the infrastructure. Now that's why we say this might be the golden age for machine learning as well. But at the same time, there are many promises of AI and machine
Hmm.
learning.
Hmm.
So those are very huge. So many of those things might take more centuries or such. But otherwise, it is just a matter of
Hmm.
infrastructure itself. Machine learning is
Hmm.
totally dependent on infrastructure and
Hmm.
data
Okay.
itself. And before, yes,
Hmm.
one more point was there. At the time, the companies didn't, capture this many data sets, right?
Hmm.
So, for
Hmm.
example, they
Yes.
didn't have this much data. Who captured this data sets? For example, in the beginning, when Facebook was built,
Hmm.
imagine what kind of data they would be saving,
Hmm.
and see now what kind of data they are saving. Like
Hmm.
what
Hmm.
kind of data where Google was, or what kind of data would they be securing at that time, and how much data they have right now. All the
Hmm.
people are moving from now, even non-technical people use technology, right? All those
Hmm.
people have data. You cannot escape technology at this particular time, right? It is impossible for you,
Yes.
right? It
Yes. Yes.
won't make
Yes.
sense to live in such age and have no
Hmm.
use of technology. Now, when you use technology, you come face to face with these tech giants, right? And
Hmm.
these tech giants, they love your data. And where do
Hmm.
they use that? They use it like this in machine learning.
Hmm.
That is what I
Hmm.
understand from all this stuff. So it is how
Okay.
how it is the way we learned to capture the data, and at the same time the infrastructure increased. That's how stuff became bigger, and that's how we came to large models of machine learning.
Okay.
Yes.
Okay. So this was a whole story about generative AI, transformer behind the story, then LLMs. Okay. So how these are connected. I think so. I hope that whole conversation was very, very fruitful for you, and also the audience will get some more insight. In future, we will record more such depth video because this was just first time as a casual talk. We try to do as much in data in draw format possible. So I think our audience will be more helpful. So thank you. Also, I'm appreciating Faizan as well. He has also given in-depth discussion all the things I'm bearing with me. Okay, so thank you so much of Faizan once again. Okay, so if you want to say something as a final message to audience, you can.
Yeah, that's it. Like, it was nice
Mm.
talking to you after so much time. So it was actually a pretty good experience for me as well. So thank you for your
Yeah,
time
yeah, my
as well.
pleasure. Okay, thank you and have a nice day. We'll see you the next episode.